Hello everyone, I hope you guys are doing extremely well. Today we are going to discuss another problem in our binary search tree series. The problem name is find median of BST. So let's understand the problem description first. So we are given a binary search tree. That means we are given the root node of a binary search tree and we want to find the median of that binary search tree. Now what is a median? A median is nothing but the mid node when the nodes are arranged in an ascending order. So if the number of nodes are even, then the median is nothing but the n by 2th plus n plus 1 by 2th node divided by 2. And if the nodes are odd, then the median is the mid node. So let's take an example to understand this. Let us say we are given the root node of the binary search tree as node 25. Now the left child of node 25 is, let's say, node 15 and the right child is node 30. Now for node 15, let's say the left child is node 5 and the right child is node 20. For node 30, the left and the right child is null. So let's arrange all of these nodes in a sorted order. So how can we do that? We can just do an in-order traversal of this binary search tree. So let's do an in-order traversal. So the in-order traversal is going to give us, we are going to start from the root node. So from the root node, we will go to its left. So we'll reach at node 15. Again, we'll go from node 15 to its left. So we'll reach at node 5. From node 5, we don't have any left. Okay, so now process the node. So we will add this node, that is node 5 here. And then is there any right subtree for node 5? There is no right subtree for node 5. So what we are going to do, we are simply going to return. Now for node 15, done with the left subtree. So now we'll process the node. So we'll add node 15 in our in order array, and now we will process the right subtree. So we'll reach at node 20. For an in order traversal, we process the left subtree first, we process the node then, and then we process the right subtree. I have already made a video on how to do an in-order traversal of a binary tree. So if you guys haven't checked it out, so please check it out and then come back on this video. So for node 20, is there any left subtree? There is no left subtree. So now we are going to process the node. So now processing the node means adding the node in my in-order array. So 20 will be added. Now, is there any right subtree? There is no right subtree. So we are simply going to return. Now for node 15, we have processed the left subtree, we have processed the node, and we have processed the right subtree. So we are again going to return. For node 25, we have processed the entire left subtree. Now we are going to process the node. So 25 will be added here. And then we are going to process the right subtree. So we'll reach at node 30. For node 30, there is no left subtree. So now we are going to process the node. So processing the node means adding 30 in our array. And now we are going to process the right subtree. There is no right subtree, so we are simply going to return from here. Now for node 25, we have processed the left subtree, we have processed the node, and we have processed the right subtree. So we'll simply return, and in the end, our in order array is going to represent us a sorted array, as we can clearly see. Now what is the median? Median is nothing but the mid node. So there are 0, 1, 2, 3, 4. That means 5 entries in this array. So 5 divided by 2 is nothing but 3. So the third node will be the median. That means this 20 will be the median. Okay, because this is zero based indexing. So in this case, our median is nothing but node 20. So we are simply going to return 20 as our answer. We are going to return an integer value. Now let's say if there are six nodes in this binary search tree, there is one more node here. Here we have node 45 extra. So what will happen? So 45 will be added in this in order. So 45. And now what is the median? Now median is nothing but the sum of two mid nodes. So two mid nodes are node 20 and node 25. That is n by 2 node. That is n by 2 is this. Okay, and then n by 2 plus 1. So this is the third node and this is the fourth node, right? Because 6 by 2 is 3 and then 3 plus 1 is 4. So this is the third node, this is the fourth node. This is zero based indexing, so don't get confused with it. So 20 plus 25 is 45. 45 divided by 2 is 22.5. So we are simply going to return 22.5. So our answer can be an integer or it can be a float. So we are going to return a float value. I hope the problem statement is clear to you guys now. So let's understand how we can solve this problem. So let's take an example. Let us say we are given the root node of the binary search tree as node 28. Now the left child of node 28 is let's say node 18 and the right child is node 35. Now for node 18, let us say the left child is node 7 and the right child is node 20. Now for node 35, the left child is null and the right child is node 40. Now for node 7, the left child is null and the right child is also null. For node 20, the left child is node 19 and the right child is node 25. Now we want to find the median. So how can we do that? We have understood how can we do that. We just need to do an in-order traversal of this binary search tree, and once we have done the in-order traversal, we will get a sorted array. Once we will get a sorted array, we will just calculate the mid node. So let's understand one more time that how we are going to do in-order traversal. I have already explained you that, but still I'm gonna do it again. So in order traversal, we first process the left subtree. Okay, so let me write it somewhere here. So in the in-order traversal, we process the left subtree of any node first, and after that we process the node itself, and after that we process the right subtree. Okay, so let us declare an empty in-order array. So let's call it array simply. Okay, so it is empty in the beginning. Now we are gonna start from the root node. So from node 28. For node 28, is there any left subtree? Yes, there is a left subtree, node 18. So we'll reach at node 18. Now for node 18 again, is there any left subtree? Yes, there is a left subtree. So we'll reach at node 7. Now for node 7, is there any left subtree? There is no left subtree. So now what we need to do, we need to process the node. So how we are going to do that? We are just going to put this value, the value of this node in my array. So 7 will be added here. Okay, now is there any right subtree for node 7? There is no right subtree for node 7. So we simply going to return from here. Now for node 18, we have processed the left subtree. Now we are going to process the node. So 18 will be added in our array. And now we are going to process the right subtree of node 18. So we'll reach at node 20. Now for node 20, is there any left subtree? Yes, the left subtree of node 20 is node 19. So we'll reach at node 19. For node 19, is there any left subtree? There is no left subtree. So now we are going to process the node. So processing the node means adding this value. So 19 will be added in my array, right? Is there any right subtree for node 19? There is no right subtree for node 19. So we are simply going to return. Now for node 20, we have processed the entire left subtree. Now we are going to process the node. So processing the node means adding the value. So 20 will be added here. Now, is there any right subtree for node 20? So yes, the right subtree is node 25. So we'll reach at node 25. Now for node 25, is there any left subtree? There is no left subtree. So now we are going to process the node. Processing the node means adding the value of this node in my array. So 25 will be added here. Fine. Now, is there any right subtree for node 25? There is no right subtree for node 25. So we simply going to return. Now for node 20, we have processed the entire left subtree, we have processed the node, and we have processed the entire right subtree as well. So we are simply going to return. Now for node 18, we have processed the entire left subtree, we have processed the node, we have processed the entire right subtree. So we are simply going to return. Now for node 28, we have processed the entire left subtree. Now we are going to process the node. So 28 will be added in our array. Okay, 28. And now, is there any right subtree for node 28? Yes, the right subtree for node 28 is node 35. So we'll reach at node 35. Now for node 35, is there any left subtree? There is no left subtree. So now we are going to process the node. So 35 will be added in my in-order array. Now for 35, is there any right subtree? Yes, the right subtree is node 40. So we'll reach at node 40. Now for node 40, is there any left subtree? There is no left subtree. So now we are going to process the node. So we will add 40 in my array. Right. Now, is there any right subtree for node 40? There is no right subtree for node 40. So we are simply going to return from here. Okay, now for node 35, we have processed the left subtree. There was no left subtree. We have processed the node and we have processed the right subtree. Now we are simply going to return. Now for node 28, we have processed the entire left subtree. We have processed the node and we have processed the entire right subtree as well. So we simply going to return. And in the end, our in order array, that is this array, will be nothing but a sorted array. And as you can clearly see, this is a sorted array. Okay, this is an array in increasing order. So now we want to find the median. How can we do that? We just need to find the length. So what is the length? 1, 2, 3, 4, 5, 6, 7, 8. So n, that means the number of nodes present in this binary search tree is 8. Now once we have figured out if n is even, so what I need to do, if n is even, then I need to take 8 by 2, that is 4th, the 4th node and the 5th node. Now in this array, it will be nothing but the 3rd index and the 4th index, because indexes are always 0 based. So 0, 1, 2, 3, 4, 5, 6 and 7. So now we are going to take the 3rd index. So 3rd index is having a value 20 and fourth index is having a value 25. We are going to sum these two values. So 20 plus 25 will be 45 and we are going to divide it by 2. So it will be nothing but 22.5 and we are simply going to return 22.5. Fine. Now talking about the time complexity of this approach, the time complexity of this approach is pretty clear. We are just doing an in-order traversal of our binary search tree, and in-order traversal is going to take us big O of n time, where n is the number of nodes present in this binary search tree. Talking about the space complexity, the space complexity of this code is also big O of n, because we are creating an array, right? So space complexity is also big O of n. I hope the solution approach is clear. This was a pretty easy problem. Okay, this was just a problem to test whether you know that the in-order traversal of a binary search tree gives us a sorted array or not. So whether you know this or not. So this was just to check whether you know this or not. So let's just convert our logic in the form of code. Okay. So as you can clearly see, I have already declared a function called find median, that is taking the root node as an argument. Root node is nothing but an object of class tree node. The class tree node is having a constructor that is initializing the value of the node. The left and the right child of any node is by default set as null. Now after this, what I need to do, I need to call a function that is going to do the in-order traversal of the binary search tree. So let's name this function as in-order traversal. Okay, and this function is going to return us a list of integers. So we are going to store it in ARR. So ARR is equal to in-order traversal. So let's write this in-order traversal function. So def in-order traversal and then root. So now first of all, what we need to check, if the node that I'm currently on is null, so in that case we need to return an empty list. Why empty list? Because I am processing all the nodes in the form of list. So if root is null, I am going to return an empty list. After this, I need to call for the left subtree. So first of all, we process the left subtree. So left answer is equal to in-order traversal root.left. After this, now once we have processed the left subtree of any node, now we are going to process the node itself. So how we are going to process the node? We are going to add this value in the list. So current answer is equal to root.value. Right. We are making this as a list because we want to sum all the list and then we want to return this in the form of a list. Okay, now we are going to process the right subtree. So right answer is nothing but in-order traversal root.right. Okay, fine. Now after this, we need to return the sum of all the three lists. So return left answer plus current answer. That means we have processed the left subtree first, then we have processed the node, and then we have processed the right subtree. So right answer plus right answer. So this is the in-order traversal of our binary search tree. Now once we are done with the in-order traversal, what I need to do, I need to find the length of our array. So n is equal to length of array. Now there are two cases. If n modulus 2 is equal to 0, that means if my number of nodes present in this binary search tree is even, in that case I need to return something else. That means it is odd. In that case, I can just simply find the mid value. So mid value is n by 2 and I need to return ARR of mid minus 1. Why mid minus 1? Because array is 0 based indexing. Now if it is even, in that case calculate mid. So mid is n by 2 and what I need to return, I need to return ARR of mid minus 1 plus ARR of mid and then divided by 2. So why we are returning this value? Because we need to return n by 2 plus n by 2 plus 1, these nodes. So n by 2 is nothing but mid. In 0 based indexing it will become mid minus 1, that's why ARR of mid minus 1, and n by 2 plus 1 is nothing but mid plus 1, so in 0 based indexing it will become mid, and then the average of these two nodes. So yeah, this is what I have returned, and that's all about the code that I needed to do. Now let's take a quick example to run our code as well. Let us say the root node given to us is node 15, the left child is node 5, and the right child of node 15 is nothing but node 20. Okay, now the left child of node 5 is root.left.left is nothing but node 2. So I'm taking a small example to run my code. So let's call this function print find median and let us pass the root node. Let's give this function a run and let's check the output of our code. So the output of the code is coming out to be 10.0. So let's verify our output as well. So we have taken this example 15 5 22. So let's verify our output as well. So 15 is the root node, then 5 is the left child of 15, 20 is the right child, and then 2 is the left child of 5. So let's do an in order traversal quickly. So starting from 15, left 5, then again left 2, there is no left, so 2 will be added, and then there is no right, so simply return for, then 5 will be added, there is no right, so it will simply return for 15, 15 will be added now, and the right is 20, so we'll reach at 20, 20 will be added. Now there are 4 nodes. Okay, there are 4 values, so the mid value is 4 by 2, which is nothing but 2. So we are going to take the second and the third value, that means the first index and the second index. So what is the first index? The first index is having a value 5, the second index is having a value 15, so 5 plus 15 is 20, 20 divided by 2 is 10, which is absolutely correct. This was the output of our code. I hope the problem statement, the solution approach, and the code made sense to you guys. If you guys still have any query regarding this problem, please drop your concern in the comment section and I will be more than happy to help you there. Regarding this series, I will be uploading more of the questions in the upcoming weeks, so keep following us. Until then, keep smiling and keep coding. Thank you.